think we could finally start this process. Let me go ahead and kind of just go back over the whole concept of this. I'm thinking this is a 3-stream project where basically today we're going to breadboard. And as we breadboard and as we finalize sections of the circuit, we will update a master schematic. So that way our schematic is updated and finalized. But hopefully the circuit and the schematic is finalized by the end of this stream. Then we'll do another stream where we do a PCB layout. So we'll go through all basically how I do a PCB design, what software I use, how we line it up with the mechanical, basically all of that stuff. So if you guys have any questions for that part, you can do that. And then the last one will, once we're done with the second stream, I'll order a prototype. That'll take a couple weeks for us to get prototype PCB. And then the last stream will be doing the art, finalizing the art and kind of the look of the pedal. And then we'll also test the prototype. And if the prototype passes inspection, if it works how we want it to, it does, it sounds, works how we want it to, then we will go ahead and open it up to like a batch to order. So like, we don't use OshPark. We usually use JLC. JLC is just really fast, really cheap too. So we'll usually order stuff through JLC. We used to do a lot of stuff through OshPark though. Back in the old day, we'd do all our prototypes. We'd get the PCBs from them. But yeah, so the goal is to basically we'll open it up to order, and then if you guys have kind of been along for the ride of this, if you guys like the sound of it, if you guys had fun, you can order one, and then just however many, if it's 10 people, if it's 5 people, if it's 50 people, whatever, we'll make those. And at that point, we'll already have a finished PCB, artwork, drill template, and everything like that. It'll just be actually getting the stuff in and putting it together. Which, hey, maybe we'll do a live stream of that, of like, hey, we're putting together the batch today. Watch us, hang out with us as we, put these pedals together. So that's the kind of idea. I hope that sounds fun. That sounds cool. Kind of got this all set up. I think this should work well though. So the general concept that I think of the starting point is this schematic here. So let me bring this up actually on my screen. So this is a 3 transistor gain stage, as you can see, very inspired by a Fuzz face. It's got a little bit of tweaks in it here and there. But it's pretty straightforward. You can see the power in, this is where 9 volts coming in. Really simple, really basic. So what I'm thinking is we go ahead and we build this schematic, and then we just start tweaking it. Maybe some more resistance here, maybe some more bigger capacitor here, such and such. Maybe we just try tweaking it in different ways, adding some connections that weren't there before. I do have an idea of, once we have this working, of something that might be cool, might sound cool. But I don't know. I want to get this working first, and then I want to pitch that idea to you and see what you guys think. So hope that sounds cool. Let's get started. So let's see here. So in here, you can kind of see we have our 9 volt plugged in here, and we have it jumped up to these power rails. This is our circuit send, basically like the input of the circuit. This is the output of the circuit. So right now there's no audio connection between them. Also, yeah, so this is a breadboard. This is what's called a breadboard. Basically all of these rows are connected vertically, but not horizontally. So if I put 2 connections in the same vertical row, they're gonna have connection, and I'm spacing the word I'm trying to think of, but they're gonna connect. Obviously, you can see that that's broken by this line. So this up here does not connect to down here, same as this doesn't connect to anywhere else. So basically, this lets you plug in components in different ways, make connections, and try stuff out without having to like solder it and it being permanent. So All right, so let's start with the schematic. All right, so we're gonna need, I think I should have all of these parts readily available, but let's make sure. So, if we come back to here, all right, so we need 100 in, and we need a 4.7 UF. We got a 4.7. All right, so here's our 4.7 UF. You know, I might grab some clippers just to make this. Oh, here's some. Just to make this a little cleaner. As you can see on the schematic, and if you guys have questions, continuity, yeah, that's exactly the word I was looking for. Thank you. If you guys have any questions, or if I'm going too fast or brushing over stuff, just shout it out. Let me know. I'd love to break down anything further. I just might not think of it. So as you can see, though, the positive leg is going away from the circuit input. So we want the cathode, or the negative end, to connect to it. And I'm just going to cut these a little bit shorter. You can see the negative end is always the shorter. It's this stripe right here. But usually it's always this shorter leg. That's how they always kind of quickly denote it. So I'm going to cut these just about kind of right there, just to keep our breadboard nice and clean. And I'm going to move this up to the top input. Actually, if we're going to do that 100 in, it should go bottom input. So I just move that there. We're going to plug in our capacitor, and we are off to the races. All right, let me scoot this over a little bit. All right, so we also have, man, I should have done a double screen of the schematic and the breadboard. But we also need this 100 in going to ground. I don't think that's actually, I don't think we need that right now. I think that was because of the input. So we're just gonna leave that off right now. Let's just go to these resistors. So we need a 100K. I gotta do it over here, I guess. We need a 100K and a 470K. Let me grab that, 100K. All right, so this is a little 1/8 watt resistor, and we're going to kind of do the same thing. This 100K is going to ground from the positive leg of the cap. So I just kind of bent it. I'm going to cut the legs a little bit shorter. Again, just to kind of keep stuff a little bit cleaner. And we're going to go from the blue rail up here, which is ground. Excuse me, to the positive leg. So let me zoom this in a little bit. So you can see the positive leg and the resistor are on the same vertical track. So right now our circuit is going in on this end, it's coming out right here, and this resistor is going to ground. All right, so now we need, let's go ahead and grab our transistor. So as you can see here, the first transistor is a 5088. Oh man, yeah, we have, do we have some? I think we have some. Oh, we don't have some. We do have some 3904s though. Not the same thing, not the same transistor, but pretty similar. They're both silicon transistors. The only difference is 5088 has a little bit more gain, but 3904 will totally work for this. So, transistor like this has 3 legs. And what we're going to do is we're going to connect the base leg, which on this, you always want to check data sheets, but on this is this middle leg. So we're going to connect this right on the same track as our resistor and capacitor. So now what we do is we have all three of those legs are on different vertical tracks, with the base connecting to the resistor and the cap. And as you can see in the schematic, that's exactly how it connects. Now we also have this 470K that's going from the base of the transistor to the collector of the transistor. Again, if you have any questions about any of this, just let me know. So let's go ahead and get that. So we need that 470K. 470K. We're going to cut and bend that. And we are going to go from the collector to the base. So you can see how, let me see where my finger is. It's connecting to this pin, which is our collector. And the other side of it is connecting back to the base where the cap and the other resistor and the base of the transistor connects. All right, so now we have our emitter, this bottom pin. I don't know if this shows, oh yeah. I don't know if this shows my cursor or not. Oh, it does, okay. I just have to click on it. So you can see this, this pin is our emitter. This symbol denotes your emitter. The direction, if you're curious, denotes whether it's a silicon, if it's an NPN or a PNP. So this is showing us that this is an NPN transistor, and we have a 2.7K going to ground. Now I don't actually have a 2.7K. We're going to try a 2K. Essentially, so what this resistor is doing is this resistor is determining how much gain this transistor stage has. So if you were wanting to have, if you were wanting the output of the transistor to be hotter, have more output, you would want to go a lower resistance. If you wanted it to be less gain, you would go a higher resistance. And that basically comes to like balancing your gain stages. So when you're using multiple gain stages, you don't necessarily want the most gain out of each transistor because you want it to sound musical, you want it to sound good. So we're going to start with a 2K resistor. Okay, so how can we get this in here? So we're going to go, let's go like right here. Still a little bit tall, but so we're catching that third, kind of hard for it to focus. Basically, we're getting that that emitter pin, and we are taking it to ground. Next, we need our 10K. So our 10K is just going to go up off the collector connection, the collector pin, and it's going to go straight to 9 volts. So let's get a 10K. Is everything still coming through okay? Can we everybody hear everything? Let me know if you guys are having any trouble. I think we're doing good now. I think the stream is working pretty good now. But let's get that 10K. We're going to connect it to 9 volts. So that's going to be the red rail. And I'm going to plug in that resistor. Not going to worry with cutting that one, trimming it down. So that one's going to positive 9 volts. And then we need a 100N. So we're going to plug in after this 100N and see how this sounds, just to kind of give you guys a reference point. 100N. And that 100N is coming off that collector pin as well. All right, so there's our cap. And this is basically a really simple boost stage. You know, this might be a little hot. Why don't we go ahead and make... So I have this pot over here, and it's going to be our output volume, basically. So one leg is going to ground. Our output to our circuit is going to be in the middle. Let's get that to plug in. And then we're going to use a jumper, one of these, and we're going to run it from the input of that pot to our cap. All right, so we should... So whereas this is our bypass, okay, that sounded horrible. What are we missing there? Make sure we have continuity on everything. Let me grab my multimeter. Going to ground. I hope it's not this switch. I haven't used this thing in a little while, but let's see here. So, let's just see if we are getting right voltages. Yeah, so we're getting 9.4. So that's connected to ground. That is going in. Let me look at this switch real fast. I hope this is fun. I hope this isn't super boring. In retrospect, I almost feel like maybe I should have fully breadboarded this ahead of time. But I don't know. I just wanted to be like, this is a hangout session and you can kind of really see the whole process. I hope it's fun. Sorry that was super loud. Something is definitely not... Oh, okay, yeah, I'm dumb. This wasn't grounded. So you got to have your circuit grounded to your input jacks. All right, we'll see if this, hopefully this works. Might be loud. Fair warning. Ah, there we go. Okay. All right. Okay, so this should be our bypass. Okay. Okay. So this is our bypass. Uh-oh. Okay. This foot switch is a little funky. It's a little old, but this is our bypass. Let me grab a pick. So that's our bypass. This is our circuit. So nice and warm. So if you guys follow these exact same steps, you would have that. So basically, let's go back to the schematic. The concept of how this works, a fuzz face and stuff like that, is this first gain stage is really just a boost. So what it does is it's supposed to boost and slam into the next gain stage, which is going to give us our fuzz. And then that slams into the next gain stage, which gives us even more fuzz. Okay? So, but this is where it's starting, which honestly sounds really good. It sounds really warm. So the boost sounds actually way more full. Just frequency wise. All right, so we're cooking. We're making stuff. We're making stuff happen. This is what I love. This is the part that's super fun. All right, so we have, oh, I gotta click on this. So we have all of this side of the circuit done, right? So now we move on to the next gain stage, which, as you can tell, really just comprises this transistor and these two resistors. You have this resistor here. What's happening here, maybe I'll explain this a little bit more when we're getting to the next gain stage. But basically what's happening here is this is a feedback loop. So you have output from the third transistor stage that's feeding back into the second transistor stage to give us even more gain. All right, any questions? Throw them out. I'd love to hear them. I'd love to answer them. Or any thoughts? We're starting to get to the point where we're going to be like, okay, well, maybe we make this a little darker. Maybe we make it a little brighter. Maybe we make it more Velcro-y. Let me make sure. All right, so we bypass this. I'm going to unhook this. And now we need another 3904. Should be a 5088. I thought I had some, but apparently I didn't. All right, so 3904 and same pin out. So I'm going to bend this middle pin back. This is just kind of how I do it. I feel like it's the easiest. Well, I guess it's not the easiest. Maybe I'm being kind of dumb. The easiest would be to just go like this and just plug it in like that. But I like to do it like that, a little fanned out. So we plug in the base to our cap, and we make sure our other pins are on different vertical tracks. You always want to make sure you're not plugging it into nothing, because that's definitely, if you're having trouble with a breadboard and it's not making any noise, it definitely could be that you just missed the wrong track and there's just no continuity. Well with acoustic. Oh, make it work well with acoustic. Sacrilege, I know, but crap. What are they called? What's the acoustics with the metal pan? It starts with an R, but I can't remember. Those sound amazing with fuzz. So, I mean, they're technically acoustic. All right, so we have our next transistor gain stage in. We need a 100R. Also, I'm old school. I think it's super important if you're going to be into circuits, audio circuits. I can't get this to focus, but learn how to read the color bands. I try dobro. Yeah, resonator. I was trying to think resonator, but yeah, dobro. Oh my gosh, sound amazing with fuzz. I tried so hard to make Jared learn the color bands on resistors, but he just would never. He didn't think it was important. I didn't know. I don't know what that was for. I just like giving him a hard time. So we're going to take this resistor and we are going to run it to ground off of the emitter pin, which is going to be this one right here. So you can see that is connected to the emitter pin. I mean, not super well, but yeah, you can see right there it's connected. Then we have a 40, here I'll show the schematic again. We have the 47K that's going to go to positive voltage. And I need to get me one of those things that lets me press a button, switch between scenes. A lot easier. That's going to positive voltage. Boom. All right, now it's starting to become a fuzz. All right, so now we have the collector is going to go into the next. Oops. It's going to go into the next transistor stage. So let's go ahead and grab that transistor. We'll connect it up super fast. Do this so you guys can see. All right, so we're going to plug that in just like we've been doing. Oh, come on. Sometimes they don't want to go. There you go. All right, so that's plugged in. And then we are going to need all right, we're going to need a 220R, 220 ohm resistor, a 1K resistor, 4.7 UF cap, and a 100K resistor. So we're going to throw all of those on. Let's see. Anything will work well with an acoustic if you've got the right live rig. I would go direct. You'll avoid the feedback issue. I saw a band use a Fuzz factory with an acoustic live, and it sounded awesome. Yeah, that would be pretty crazy. Astronomer sounds amazing on acoustic, if I do say so myself. I think it is one of the best combinations. Oh yeah, so we don't have a 220R. So a little trick, especially when you're breadboarding. If you don't have a value, you can use two smaller values in series, which means one going directly into the next one, and those will compound. So I have two 100Rs, run them into each other in series, and that's going to become 200. It's not exactly 220, but it's close enough. That's going to be off the emitter pin. Let's cut these down. So the emitter pin. We have another one. Actually, let's do this. When you're trying to save space, you can bend them vertically. And you don't have to jump as many spaces. All right, so that's going to go right there. That's where we're at right now. All right, so after the 200, so over here, we need that 100K to jump back over to the base of the second. So we're going to leave this one long. It's got to go from here all the way to over here. And obviously that you don't want any things to touch that shouldn't be touching, because that would sorry, create continuity and make the circuit interact in a way you don't want it to. All right, so if we look back at our schematic, we've got our 200 taken care of. We've got this 100K. Now we just need this 1K and this 4.7 UF. So let's add that. So we need a 1K. All right, that 1K is going to go to ground. And our 4.7 UF, just like before, we're going to trim that, and that is also going to ground in parallel. I think I got that in there. Maybe cut it a little short, but our connection's there. All right, so this whole part is now done. Did we do this 47K? I don't think we did. No, so we need this 47K to go to positive voltage. 47K. Just plop this in here real fast. You can see why clipping and keeping your board clean can really help keep you from getting continuity errors that you don't want. But we're kind of skipping ahead. We're just trying to get to fuzz as quickly as possible. Now, oh wait. Oh wait, that was the wrong one. Okay, so there's not a 47K there. Wrong gain stage. We have a 5.6K. We don't have a 5.6. So we're going to use a 5.1. See how it sounds. So off the collector, I'm going to use it to jump all the way over here so we can kind of mess with that a little bit easier. So we got that 5.1 resistor going on there. And then we're going to have a 1K going up to 9 volts. After that, we have a 100N, and we're pretty much done with this. There it is. Boom. Now I did kind of mean to stop at the second gain stage, and we could still jump it in there so you could see how it sounds. But are you guys ready to hear how the fuzz sounds? Let's see, where did my jumper go? So let's connect it to the volume. Connect it to the 100N. We're gonna actually wire this pop backwards. But you ready to hear how it sounds? Hopefully it's not bad. Let me know if this gets too loud, but so we're getting a little bit of feedback there whenever you stop playing. We might want to tweak that out. It's a little too aggressive, I think. Yeah, so um, that's not really vibration feedback. So traditional vibration feedback, as you may well know, is when you have an amp rocking and just the sound waves are vibrating your strings, you know, and you hold your guitar up to your speaker and it starts feeding back. This is more of a circuit feedback. So that 100K that is doing a feedback loop, it could be that we tweaked a couple values. So the the first gain stage might be hitting the second gain stage too hard. Um, I did want to kind of show you guys some fun that we could have with the circuit overall, though. Maybe let's try tweaking the. So what I'm thinking of, let's try lowering this resistor value right here, because we only put in a 2K. And just a 0.7 might not seem like a lot, but on this specific control right here, that's gonna make a big difference on the gain of this transistor. So let's try tweaking that to a 3K. Oh, I don't have a 3K, but I have a 3K3. And that'll also show you guys like the effect of how the difference that'll make. So this is the fun part, going back in and figuring out where that resistor is. All right, so it's going to ground, so it's going to be this one. And we're just going to put this in here, this in there. All right, this switch is driving me a little crazy. Oh, is that too much? All right, there we go. All right, so there's our bypass. Here's our fuzz. All right, not really what I expected. So I don't think it's that gain stage. So let's actually put that 2K back. Oh, I just dropped it. Let's do K. So I think the problem might be that feedback loop then. Let's see here, because when we put more input into it, it didn't sound so arcadey. Also, if you guys have any questions, if you guys want to hear something specific tweaked, throw it out there. Yeah, so that actually articulated more when we pushed that second gain stage more. Well, let's see. We were a little bit off. We didn't have the 220. We just had 200 ohms right here. We did that right. I guess let's try tweaking this with R7. Let's just try pulling R7 and seeing how this sounds. So R7. Going from stupid switch. Okay, so I don't think the circuit like that, I guess. Let's just try putting something higher. That can't be the next value. Okay, here we go. Next highest value I have is 150. 150K. Let's try that randomly. From boom to base. Yeah, to the base. What did I do? Okay. Sometimes you just gotta go back a step. Is I in the wrong one there? Sorry about that. Didn't like that. Definitely sounds way better. All right, so let's try jumping to just past the second gain stage. Actually, this might not work. There we go. Okay. Well, let's try adjusting. Sorry, I'm looking at the schematic here. Let's try adjusting R5 a little bit so it's a little bit less gain. So let's try going up to a maybe a 200R. Oh yeah, we don't have a 200R, of course. All right, let's jump up to a 470R just for a quick testing. So that was the second gain stage and the emitter going to ground. Just gonna be this guy right here. You always want to be careful you're not unplugging something else on accident. You have to pull something out. Okay, let's try that. All right, so we had a 47K to positive voltage. Yeah, let's try a smaller value. Let's try 10K. that's a good sign. Okay, so maybe not such a big jump. Maybe not a huge jump, like 10K. We were at 47K. Let's try 39K. Thank you guys. If you guys are still with us, I hope you're having fun. Still kind of high. You know, I kind of want to try putting this back as 47K. And then try adjusting this 1K we have over here. .6K and then this 1K. Let's try upping that to a 10K. So really Velcro-y. Let's try a smaller jump. So from 1K to 2K. This might still be too much gain. Okay, let's try 4K7. Split the difference. So the that like Velcro-y sound it can be caused by a couple different things, but here I think what's happening is the basically the bias of the transistor is off. So the positive voltage, you could voltage starve transistors to make them more Velcro-y. I think that's basically what's happening. It's funny because I've built this before, but I never had this feedback problem before. I'm wondering if we just did something wrong. I don't think we did. But we were off on a couple values. So it might just be that. We had 5.6K. See, we didn't have 5.6K. We had 5.1K. Yeah, I'm just wondering if a couple little things like that have it kind of sabotaged us. But do you guys like that sound? Do you guys like it being Velcro-y? Could the switch you are having issues with be doing unexpected things? I don't think so. I don't think that's what's happening. But you know, you never know. Let's do this. So add 100 in right there, and then we're going to punch into this second gain stage. let's get rid of that 47K. Do something like a 10K. Put this back in. Also, though, a good point is this circuit is supposed to be using 5088s, and we're using 3904s. Let me check something here real fast. Get a little reference. Okay, so we had a 47K in there. Let's try just something smaller like 27K. That we go in there. We have this one. Can you tell if that's a 1K or not? Set this back as a 1K. Just in case that wasn't. There we go. Cleans up well too. Yeah, I think that sounds pretty good. I don't know what you guys think. If you want to throw out any thoughts, but that's what's fun about this. I mean, I actually like. You obviously there's tons of reference points out there. Tons of people have designed fuzzes. You can bring up other people's schematics and get ideas, and that's great. I personally love doing it like this, where I kind of had a rough draft, but then I just wanted to get in there and tweak with values until I kind of got it to how I wanted it to sound, you know? I'm a bass player. How easy is it to add a blend knob? It's not hard. I mean, for this project, we're just trying to do a one knob fuzz. But basically, to do a blend knob, you would want to have, so this basically, this would be your gain circuit path, and then you would want a parallel clean path that then you mix together using an op amp would be the best way to do it. You op amp blend those together, and then you have your output, and then basically you'd have a knob that biased this circuit to low. You know, basically you could turn it down. I guess if you were wanting a single knob to blend, you would want it to turn up one side while turning down the other side. Not super hard, but not something we would cover in this. Maybe in a different video or a different project, we could go over how to do that. One thing I did want to kind of play with is, let's take a 10K resistor. I was talking a little bit earlier about voltage starving, right? So we're going to take a 10K resistor, connect it to the positive rail. We're going to disconnect the master positive connection, and we're going to connect it to the other end of that 10K. So now there is a master 10K resistance to 9 volts. This is what like voltage starving would be. So if you know, people even make external products that you can use to voltage starve. I'm just curious. Whoa. That made a way bigger difference than I thought it was going to. Maybe 10K is just too much. Let's try like a 1K. This is a 1K8. So it can get weird. Again, this is your clean. So guys, I think that is kind of it. Unless there's any input from you guys where you are like, hey, I'd like it to be a little bit more like this. I'd like it to be darker. I'd like it to be brighter. I was kind of hoping this would be like a group, you know, kind of experience, but I totally get if you guys like how it sounds or you're not really sure what to tweak or what you would want different. That's totally cool. I'm pretty happy with how it sounds right now. Which, if that's the case, then we would probably just move forward with it like this. my ear, with going between my pickup selection on my telly, which is, you know, obviously a brighter guitar. I think the bright balance at least is Can you make it sound more like my Aunt Ethel's voice? She was a smoker. None of that is true. Extra 10 points if you can name that song or band. Yeah, guys, I think that's pretty much it. So, I mean, really, the purpose of this was to show you, like, how it works to use a breadboard to do a circuit. As you can see, it's really not that many components, but it's taking the time to dial them in and the quality of components that you use. And then obviously the next step would be to translate this into a PCB that's going to be reliable and really quality. Excuse me. Let's see, thick sounding. Hopefully you finish it up. It sounds awesome. Yeah, so that's pretty much it. That's how you would use a breadboard to design a circuit with resistors, capacitors, and transistors. That's all we used on this. So, yeah, if you guys, tobacconists, if you guys like this, or if you're watching this after it's streamed and you have any questions, I will answer any questions after the stream is over. Just leave your comments below. If you like this, also follow us. I would like to do more content like this. Like I said at the start, we have 2 more planned to go along with this one of just basically finishing up this project so that you can see basically start to finish what the process would be for launching a guitar pedal or designing your own guitar pedal at least. I'm pretty happy with this. I like how it sounds. I had fun hanging out with you guys. Thank you for hanging out with me. Thank you for bearing with me through all of the errors and issues and stuff we ran into. I think that's pretty much it. That's all I got, guys. Yeah, I will post. I'd like to do the next part within a week. So if you follow us on Instagram, social media, and stuff like that, just keep your eye open there. You'll see us schedule the next live stream. I don't want to call it. I have a bad habit of calling it out and then like a life thing coming up where I'm like, oh, I literally can't stream that time or that day. So I will try to really concrete what the next one will be. Hopefully on a Saturday or Sunday though, because I feel like that's way more available to people to be able to watch and participate. So yeah, keep your ears open. Thank you for all the support, hanging out with us. I had a great time. I hope you guys had a great time too. And I will see you guys next time. All right, thanks.